In this video series, I work through a math problem or problems each video. Linear programming is a way to solve a problem with multiple linear conditions, which can be expressed as a list of linear inequalities. Graphing the solutions to all the inequalities gives us a region of points that represent the solutions to all the inequalities. In these problems, we're usually asked to find the point in the region that either maximizes or minimizes a certain expression. Though there are infinitely many points in this region, we only have to check the coordinates to the vertices to find either our minimum or maximum. Let's take a look at the example. It takes 3 hours to make a medium-sized cabinet, while it takes 2 hours to make a small cabinet. The medium-sized cabinet can be sold for $25, while the smaller cabinet sells for $15. You can spend only 30 hours per week making these cabinets. To meet demands, you always make at least 2 medium-sized cabinets and 3 small cabinets. How many of each type of cabinet should you make to maximize your profit each week? The two unknowns that we're trying to solve for are the number of medium-sized cabinets and the small cabinets that we're trying to make. So let's use the two variables x and y to represent these quantities. I'll use x to represent the number of small cabinets that we're going to make, and y to represent the number of medium-sized cabinets that we're going to make. Since we had to make at least 2 medium-sized cabinets, that means that the quantity y has to be greater than or equal to 2. And since we had to make at least 3 small cabinets, x has to be greater than or equal to 3. Next, let's take a look at the time constraint. We only have 30 hours to make these cabinets. And let's see, we have 2 hours to make the small cabinets, so the amount of time that we spend making small cabinets is 2 multiplied by x, and the amount of time that we spend making the medium-sized cabinets is 3 times y. If we add them together, we find the total amount of time that we spent making these cabinets each week, and this quantity cannot exceed 30 hours. Let's solve this inequality for y so that we find the equation for the boundary line. We subtract 2x from both sides of the inequality, then divide by 3. So that gives us y is less than or equal to minus 2/3 x plus 10. Let's go ahead and solve the boundary line, which is y is equal to minus 2/3 x plus 10. The y-intercept of this line is 10, and the slope is minus 2/3. We can actually use the x-intercept to help us graph this equation. So let's say that to find the x-intercept, the y-coordinate has to be 0. So if we plug in y is equal to 0 into the equation, we get 2x is equal to 30 and x equals 15. So this is another point on this line. So let me just connect these 2 points to draw the boundary line. And to find out which half plane to color, let me use a point 0, 0. If I plug in 0 and 0 for x and y, we get 0 is less than or equal to 30, which is true. So this half plane is the part of the plane that we're looking for, solutions. Next, let's graph the inequality y is greater than or equal to 2. that will be this line at y is equal to 2, and any number bigger than that. So this region here represents the solution to this equality. And we also have x is greater than or equal to 3, and that will be this line. So we find the point 30 on the x-coordinate, or I'm sorry, the x-axis, then draw a vertical line. Then all the points to the right of this line represent the solutions to this inequality. So if we look for the region that's common to all three half planes, then it will be this triangle right here, including the boundary lines. So this is the region that we're interested in, and this is where we're looking for solutions. Next, we need to find the vertices of this triangle, since those are the points that has the possibility of being the maximum or the minimum. This point is, as we've said earlier, 3, 2. We said that the x-coordinate is 3 and the y-coordinate is 2. So the coordinate of this point is 3, 2. And we know the x-coordinate of this point right here, it's 3. And similarly, for this point, we know that the y-coordinate is 2. Okay. And next, let's try to look for the missing coordinates. For this point, the x-coordinate is 3. So if we plug that into the equation here, x equals 3, so 3, 3, they cancel out. Minus 2 plus 10 is 8. So the coordinate of this point is 3, 8. And for this other coordinate, the y-coordinate of this point is 2. If we plug in 2 for y, we get 6. 2x plus 6 is 30. 30 minus 6 is 24. And 24 divided by 2 is 12. So 12, 2. So these are the coordinates that we need to use to find the maximum of the maximum profit that we're looking for. And we need to find expression for the profit. And that's given by this statement right here. The medium-sized cabinet can be sold for $25. So if we take the number of medium-sized cabinets and multiply by 25, that's the amount of profit that we're going to earn from the medium-sized cabinets. And we only get $15 for these small cabinets. So we multiply 15 by x, then add these two quantities together, and this is equal to the profit. So this is the quantity that we're trying to maximize. So let's start with the point, say 3, 8. If we plug in 3 for x and 8 for y, we get 15 multiplied by 3 plus 25 multiplied by 8. 15 times 3 is equal to 45, and 25 times 8 is equal to 200. So if we add them together, we get 245. Next, we need to try the point 3, 2, but if we compare these 2 points, we're making the same number of small cabinets, but we're making a smaller number of the medium-sized cabinets. And in that case, the profit can't be greater. So even before plugging in these coordinates into the profit equation, we know that this is going to be smaller. Since we're interested in maximizing the profit, we won't even need to try this point out. And finally, the last point that we need to consider is 12, 2. Okay, let's plug in 12 for x and 2 for y. 12 we can actually write as, let's see, 4 times 3. Then 15 times 4 is equal to 60. And 60 times 3 is equal to 180. Then 25 multiplied by 2 is equal to 50. And 180 plus 50 is equal to 230. Since 245 is bigger than 230, we want to make 3 small cabinets and 8 medium-sized cabinets, since that maximizes our profit.